1964, first generation. The Mustang launched in April 1964 using the Falcon platform because sharing its unibody structure, front suspension, and drivetrain components reduced development cost and enabled Ford to produce over 400,000 units in its first year. Ford offered inline-six engines like the 170 and 200 cubic inch alongside V8 options up to the 289 because it needed to cover both entry-level buyers and the growing demand for affordable performance. In 1965, the GT package added front disc brakes, stiffer springs, and quicker steering ratios to improve braking consistency and stability at sustained highway speeds. The model surpassed 1 million units, sold in less than 2 years because its low base price combined with optional performance packages attracted a broad customer base. The long hood, short deck layout became the standard for pony cars because it allowed longitudinal engine placement while maintaining a relatively short 108-inch wheelbase. Mustang II. In 1974, the Mustang was redesigned on the Pinto platform because the 1973 oil crisis forced manufacturers to prioritize compact size and improved fuel economy. Ford removed V8 engines at launch because new EPA emission standards and fuel economy regulations restricted large displacement engines and increased compliance costs. In 1975, the 302 V8 returned after strong consumer demand, but with output reduced to around 140 horsepower because emissions equipment limited engine efficiency. Rack and pinion steering replaced recirculating ball systems to improve steering precision and low-speed maneuverability in urban driving conditions. Reduced vehicle mass, dropping by several hundred pounds compared to the previous generation, improved fuel efficiency because less weight required, less energy for acceleration. 1979. Fox body. In 1979, the Mustang adopted the Fox platform because Ford needed a lightweight unibody architecture shared across models like the Fairmont to reduce production costs. The lighter chassis improved power-to-weight ratio when paired with 5.0-liter V8 engines, especially as output climbed above 200 horsepower in the mid-1980s. In 1982, the GT returned because consumer demand shifted back toward higher performance vehicles after the fuel-conscious 1970s. Electronic fuel injection replaced carburetors in 1986 because precise fuel metering improved throttle response, fuel efficiency, and emissions compliance. The solid rear axle was retained because it handled high torque loads more reliably while keeping manufacturing costs low. In 1994, the Mustang received a redesigned body while retaining a heavily revised Fox-based chassis because reusing the platform reduced engineering and tooling costs. Structural reinforcements, including additional bracing and stronger subframes, increased chassis rigidity because improved stiffness enhanced crash protection and handling response. In 1996, modular 4.6-liter engines replaced pushrod V8s because overhead cam architecture improved airflow efficiency and combustion control. Dual overhead cam variants in Cobra models produced up to 305 horsepower because increased valve control allowed better high RPM performance. In 1999, the New Edge redesign introduced sharper body lines because angular styling aligned with late 1990s automotive design trends. In 2005, the Mustang moved to the S197 platform because the Fox-derived architecture could not meet updated safety, rigidity, and crash standards. The exterior design incorporated 1960s-inspired proportions and details because retro styling had strong consumer demand in the mid-2000s market. A 3-link rear suspension with a panhard rod improved axle control because it limited lateral movement of the solid rear axle under cornering load. In 2011, the 5.0 Coyote V8 was introduced, producing over 400 horsepower because increased output was necessary to compete with modern muscle cars. Aluminum engine construction reduced engine weight by dozens of kilograms because lower mass improved front-end balance and overall handling. In 2015, the Mustang was engineered as a global platform because Ford expanded official sales into Europe, Australia, and other international markets. Independent rear suspension replaced the solid axle because multi-link geometry improved grip, stability, and ride comfort on uneven road surfaces. The EcoBoost turbocharged 2.3-liter engine was introduced, producing over 300 horsepower because smaller displacement engines improved fuel efficiency while maintaining performance. Direct fuel injection improved combustion efficiency because high-pressure fuel delivery allowed more precise control under varying load conditions. Selectable drive modes adjusted throttle response, steering weight, and stability control because electronic systems enabled real-time adaptation to driving conditions. In 2024, the Mustang retained an updated S550-based platform because developing a completely new architecture would significantly increase production and development costs. The interior adopted dual digital displays, including a large configurable instrument cluster and infotainment screen, because integrated systems centralize vehicle information and controls. A fully digital cockpit replaced analog gauges because software-driven interfaces allow customizable layouts and real-time performance data visualization. Naturally aspirated 5.0-liter V8 engines were retained, producing around 480 horsepower because strong market demand remains for traditional high-displacement performance. Updated electronic control systems manage engine response, transmission behavior, and traction systems because integrated software allows real-time adjustment of vehicle dynamics.